Man, we just finished doing some go-kart racing. We just went down to this like open track. We did 250 laps. 250 laps. It was absolutely insane. My body is so freaking sore. But back to the topic of the video. Project Sentry. So everything's still been sitting here gluing since the last time I let it sit. I did try to fill in the nose a little bit. Let's see if you can see it. Yeah. So what we're going to do in this video, we're going to start sanding the edges of this to knock that lip down. We'll start sanding the bottom all the way around and get these sponsons ready to go. We're going to make a tang to come off of this to come back for a trim tab. I'll make it really long to begin with, and then I will look for the happy medium of where the boat kind of balances, and then that's more or less in the area where we'll put the trim tab or the turn fin, I guess. And we'll start sanding the boat. I've got to go inside and get the stuffing tube, the liner, and the flex cable, and we'll get that finagled in here. And I've also got to build the ski. I've got to sand the rear transom completely smooth, because you can see, I don't know if you can see I've got a little bit of glue buildup. Yeah, you can really see it right there. So I'll probably just take a razor blade and slice that, and then I'll take some probably some 400 grit, and then we'll just take the whole boat kind of like this, and we'll sand it down, because I do not want to hit that with my belt sander. But we're going to work on this a little bit, and we'll take you along with us. All right, we're going to jump straight into it. So I'm going to say I've got these 90% of the way done. I still need to do some work on the bottom of them. You can tell, still got a little bit of glue there. I strictly did these with the belt sander, knocked off all the high stuff. I've got a piece of sandpaper wrapped on carbon fiber that I'm going to use to flatten the bottom and sharpen the rear edges, because I want water to break off the rear. I don't want to roll them over like I did the old one. And I'm going to spend a lot of time on the sponsons. And we also got to make sure that when we put the boom tubes in, that they are level, like with one another, and they're not cattywampus. So we'll take into account, we'll measure that they are the same distance from the front holes and the back holes. And as for the tub, went ahead and sanded this really well. I've already got fingerprints on it. It's so terrible. Carbon fiber dust, man. It will literally get on everything very quickly. It was so nice and clean 35 seconds ago. But sanded the top, all the edges, sanded inside of here, any spots where I could get a splinter. So now this is all smooth. Got the rear transom. You can see where I was sanding on that, and then I had to go in with a razor blade and start slicing the glue. So I still need to go in there and dress that up just a little bit. I've got a little bit of glue still right there where the rudder's going to go. But once I get that all cleaned up, then we will start the process of mounting the rear strut and the rudder. Once we get the strut mounted, then we can kind of figure out where we need the stuffing tube and all that. So it's a lot of back and forth. Hold it there, measure it, maybe drill it there, maybe not. There's just a whole lot that's going to go on. Don't want to make a mistake. Now we've got the tub pretty much where I want it as far as angles and edges, right? So what I'm thinking about doing for the rudder, I'm thinking if I can square it up perfectly with the top and the edge, that'll give me a beautiful mounting location. It'll be nice and streamlined down the side of the hull. This is a longer rudder. I think they sell 70s and 90s millimeter lengths. I think this is a 90. I'm not 100% sure on that. But yeah, see, this is the long version, 52 mil. Maybe the short one's 45, I don't know. But maybe the total length is 90. Hell, I can't remember. But I need to disassemble it and put some Loctite on the inner screws so we don't have that back out. But we've got a really nice hole. Like, I'm not gonna re-drill this. I don't want to ruin it. It's got decent size cooling. The pickup's nice. The bigger you make it, the harder it's gonna, you know, drag. And I'm really thinking about switching the rudder and the turn fin to something with the consistency of a razor blade, super thin, and just for speed running, right? So it's less drag resistance on the water if I can put something in there. And I may even make it out of carbon fiber, I don't know. But, you know, I think I can make something like this out of a piece of an aluminum stock. And I've watched enough of Cozy RCs to know that it can be done. All you have to do is put in the man hours. But with the width of that blade, that's pretty good amount of drag. So if we can knock down drag by running a true razor blade thin stainless steel sharp blade in the back and in the front, it might work, you know. And then I would have to convert to a blast pickup, which I'm thinking, like, picking up ideas off of Oxydine. He uses the back of the ski with aluminum pipe going in it. I think he actually has pickups. But why can't you take a ski and put an angled tube in it and then come out and then curve back in and then slice it smooth with the bottom of the ski to get watered there? I'm not sure if that's a viable option. Seems cool. But if I did it that way, I'm kind of like ruining the ski by drilling a hole in it. So I think maybe a blast pickup will be my best option for minimal drag in the water. But I'm going to go ahead and mount the rudder, and I'll show you when it's done. Well, it's been a few days since the last clip you just saw. I hadn't done a lot of filming on this, but I'll basically jump in and kind of show you what I have done. So we've got the servo tray glued in. We've got the stuffing tube glued in. That's epoxy mixed with Cabosil. I still have to go under here with some sandpaper and sand this smooth. Now all of this is going to end up getting covered with a ski, right? So this is a ski. It's not the ski. So I'm going to rebuild the ski. This was kind of like my test. Not 100% satisfied with it. I think so much of the speed on these boats relies on the design of the ski. So this front to back is 7 inches. At least I think it is. But 7 inches, and I'm going to try to basically duplicate as much as I can from this build here. We've had this at 91, so I'm basically trying to do a copy of the ski that's on here, which this I think is a little bit better wood, but someone had made that ski for me and I'm trying to duplicate it. So it'll be the first time I'm actually making a good ski. Now I still have to do the nose cone. That'll be probably the last thing I do on the boat. Right now it still gives me access to the front when I glue the sponsons in. So the ski can be one of the final things we do to the boat. But for now, we've got the rear strut assembly on. I'm opting to do this one a little bit differently. You can see how I've got this strut and then compare it to how I got this strut. So this is actually the right direction. On this one, I flipped it around backwards. These were 4mm struts, and I decided to just take a drill bit, put it in the drill press. We drilled it out with a 3/16 bit and pushed in some brand new Octor bushings. I'm not sure if it was a 1/4 inch, 3/16. Yeah, I think it was 3/16 that we drilled it out with. Can't really remember. It doesn't really matter what drill bit I used. But you just basically find the drill bit that is the same outside diameter as your bushings and put it in something straight and drill it. And it seemed to work okay. And then you saw in the last clip how I got the motor all lined up. And I will have to test that, so we'll test that here in this video. We're going to go ahead first. We're going to mount the servo. We're going to drill a hole for the servo rod. Then we're going to mount the rudder, get all that hooked up and you know, looking good. Because of the mount on this strut, it takes up a lot of the portion of the back of the boat. It takes up a lot of that rear transom. This one here was a micro strut mount paired with a different strut mount. So that was 2 kits and I robbed this piece here, and then I used that to mount this, if that makes any sense. So that's why I had an extra one of these left over, but I opted to just go with the brushed nickel look. That was pretty clean. And I don't know if it's the right angle yet. I think it's the right angle. I'm trying to get as neutral as I can, but I'm sure I'll be able to manipulate it a little bit up and down if necessary. So like I said, I'm basing a lot of this off of this build. I tried to figure out how far that strut was down, but yeah, so a lot of it's guessing. And then you'll, you know, if you aim high, you aim low, you shoot for somewhere in the middle kind of thing, you know what I mean? So that's what we're going for. I'm gonna go ahead, do a little work, mount the servo, get all that, and we'll jump back in here and I'll show you once that's done. Then we will mount the motor and we'll start focusing on the ESC. I've got the Fly Color Wi-Fi card, that way we can get data. And another thing I'm going to do to this, we're going to open this up a little bit. I'm going to solder on a capacitor bank. I've got an additional cap pack. I think this ESC would highly benefit from an additional capacitor set. So it's only got 2 caps on it now. We're going to add 4 more and try to find somewhere in the boat to fit the capacitors, because I think it's going to be helpful, especially since I blew one of those ESCs up already. But that's the direction we're going. So I'll show you how far I get along with it tonight. So I'm having a little trouble with trying to figure out my through hole for my rudder, right? So I'm going to use this piece right here on the actual rudder itself. And I had a rubber boot, but if we try to use the rubber boot, there's not enough room here for the boot. And the boot in itself is just way too big, and this is the small boot. So what I have here, I believe this is 5/32 aluminum tube, which is perfect, absolutely perfect diameter for the rod, right? For the servo, the rudder rod. This rod's gonna go from the servo to the rudder. And I've gotta find a way to get through the hull, through the transom, and manipulate it. But if we go straight like so, we're kind of like right in line with the rudder, so we're going to have to bend it. And I think we're going to actually have to bend it on both sides. So we're going to have to do a little Z-bend here and maybe a little Z-bend here. Well, if I do that, I'm not going to be able to get the rod out ever, right? And theoretically, you shouldn't have to get the rod out. Now, I'd cut this piece, and it was twice this long, but I ended up having to drill it out because it was cocked at an angle, which made the rod go downward. It's kind of hard drilling through double layers of carbon fiber and having a straight hole. So I went ahead and drilled it out, and then now that it's shorter, I can kind of keep that in there. My goal here was to just have that little bit of a stub sticking out and then put the rod through it, put a piece of heat shrink on it, heat shrink it down, and then just have the rod kind of slide through the heat shrink. Or pack it full of grease, and then the grease kind of be a water deterrent, and it do that way. As long as I have a little bit of grease and some heat shrink on one side or both sides, then I think that'll seal. So that's kind of the direction I'm headed for with the rudder arm. It's so much going on back here in such a small little area. That's what makes this difficult. So just thought I would share this little bit of frustration with you. When it comes down to getting to the final touches of things, you know, I want to put it together, make sure it's good, then take it back apart and then put, you know, silicone on all these screws and put them back in so it's watertight. That's the goal. You know, I can't back myself into a corner. So that's what I'm trying to prevent here. I finally got the steering done, and it took me about an hour and a half, and it's not the prettiest in the world, especially back here, because it was hard to bend this stuff. It's really hard, and you gotta have it through the hole in order to bend it, and then once you bend it, you gotta not let this piece up here rotate, which was hard because I made it to where it would rotate, and that piece inside of there is nice. You know, that's got a nice bend to it, but this is supposed to be able to manipulate up and down a little bit if necessary to roll with this. And then when I tried to bend this, it didn't bring it over enough, so I ended up having to kind of squeeze it back down. But it's functional. It's functional. I'm probably being a little too OCD about it, but that's why on my old rigger over there, I've got a really skinny wire. If you see how skinny that wire is on that one? That was why I did that. And then what we were learning is that under load, right, when you try to push the rudder, it bends that wire. So that was why I would have a hard time turning that thing, or it would dart, because it would bow that just enough to where it would make the boat wander. So trying to make mental notes from one to the other and fix it. Now I had to end up taking the strut off in order to get in here, so we've got to put the whole strut assembly back on and all that, which is fine. But yeah, so we got the steering done. I still have to align the rudder. The rudder's still cocked just a little bit. I need to loosen the screws. If you'll notice, I got this one in backwards. It was just easier to put the bolt in from the inside and put the nut on the outside. Simple as that. I tried a dozen times to get the nut on, and it's so close to the top in there. I can't get in there with the servo in there and everything. So not easy boat to build, y'all. Not an easy boat to build, especially when you're doing something crazy. But I can't mount the motor until Offshore Electrics sends me the 4mm coupler. Now, this 4mm coupler here has 2 set screws on it. And what I'm hoping is that the one that I just ordered, they finally got it in stock. It shows a picture with 1 grub screw. So I'm hoping it's short, because this is long, right? And you let me know in the comments. I was thinking about taking it to my bandsaw and cutting half of that off, because I don't need 2 grub screws. I don't need it to be that long. I could take 1 grub screw out and cut it right through that second grub screw there and shorten it up considerably. I don't know if that would mess with the balance of it at all. As long as I cut it square, I think I'll be all right. But my old setup with the 1/8 inch shaft, it had a collet that was 1/8 inch to 1/5 and I wish I would have ordered this motor in 1/8 inch shaft. I just thought 4mm would have been stronger at such high RPM, and it may still be, but the collet selection on an 1/8 inch shaft is far more than 4mm. So that's the dilemma I'm having there. So I've already placed the order. I've got a couple of little odds and ends coming. So once that comes in, then I can mount the motor. And then once I mount the motor, I can place fitment for the ESC. I'll show you here on the ESC. I went ahead and took the clear wrap off the ESC, and so I wanted to test this. These right here are 90-degree fittings for the Hydra, and they fit this fly color cooling jacket, right? So here's the reason why I'm gonna do it. And I've got it backwards right now, so don't mind me there. I wanted to see if the 90-degree fitting would fit for this side here. So I can do a 90 here, and instead of having the pipe go up and loop up where the battery is, I can have my cooling line basically come straight up and then wherever I need it to go. I'll probably run a straight one back here, but I'll definitely run a curved 90-degree fitting up here. I just think that's going to be the smoothest way around here, you know. But we're definitely going to desolder these wires and put bullet connectors on them to where we can just go boom straight into it with the motor. Or I could theoretically just solder the motor wires right onto the board. You know what I'm saying? There's a few different ways I could go about doing it, but I'm just trying to make it compact as possible and learn from what I had over here. And because we did that here, we did that with the bullets. See the bullets? It really helped compact and take all those wires out of the equation. You know what I'm saying? So I've yet to see anybody shove anything bigger than 100 amp ESC in these shrimp riggers. This is a 150, that's a 120. You can do the Fly Color 90. I just don't know if the Fly Color 90 could handle 5,000 kVs. But I'm going crazy with it, super high RPM. I'm gonna see what we can do on 3S. Hopefully it's capable of insane speeds on 3S. If I can order like a 3000 milliamp pack, I think it would carry a little bit more power than the 2200s. I'm just kind of waiting and seeing. Right now I've had really good results out of that Roaring Top, the ADC Roaring Top 2200. So I need to check Roaring Top to see if they have any batteries that would fit. I need the same height, the same width, but the length can be different now. I can run a longer battery with this setup the way I'm going to do it. Just a lot of fitment issues and stuff like that. You gotta make it perfect. Gotta make it perfect. So I'm gonna go ahead and end the video here. I know this is a little bit shorter. I don't want to add all the other excess stuff to it because we're still waiting for parts. Probably gonna be 3 or 4 more days for all those show up. So I don't want to put the sponsons on and all that stuff until I get all the electronics in the boat. So this video was basically just the steering, which we got the steering done, and I'm satisfied with it enough. So I'm gonna go ahead and end it here. Thank y'all for watching. Go ahead, drop your comments in the comment section. Let me know what you think. Give me a little idea. You know, any information, any insight is valuable. So thank y'all for watching. We'll see y'all on the next one. Peace.